Assalamualaikum, my name is Muhammad KHAIRIL. So I'm going to present about introduction and literature review on solar power. Okay, solar energy converts sunlight into electricity either directly through photovoltaic or indirectly through concentrated solar energy. Concentrated solar systems work by focusing a large amount of sunlight into a small beam using lens or mirrors and a solar tracking device. Photovoltaic cells turn light into electricity using the photoelectric effect. Early photovoltaic applications range from single solar power computers to detached residents with off-grid photovoltaic systems on rooftop. A solar cell, also known as a photovoltaic cell, is a device that converts light into electricity. The first solar cell was created in 1880 by Charles Fritz. A PV system generates direct current electricity dependent on the amount of sunlight. Inverters frequently convert voltage or alternating current (AC) for practical use. The modules contain numerous solar cells. Arrays of modules are connected to an inverter which creates energy at the specified voltage, frequency, or phase for AC. Many household PV systems, especially in developed countries, are connected to the grid wherever possible. These grid-connected PV systems don't need energy storage. Solar thermal power (CSP) is a type of concentrated solar power that employs heat generated by typical steam-driven turbines to make electricity. The parabolic through the compact linear Fresnel reflector, the Stirling dish, and the solar power tower are popular concentrating technologies. Various methods are also used to monitor and focus light on the sun. Each method uses concentrated sunlight to heat a working fluid to generate electricity or store energy. Thermal storage allows efficient power generation up to 24 hours a day. The photovoltaic cell installed on the roof of the house collects the solar energy and is used to warm the water. Sun's thermal energy is used in office, warehouse, and industry to supply power. Solar energy is also used for public transportation such as trolleys, buses, and light rails. For literature review, a value chain view requires knowledge of how solar systems are conceived, manufactured, sold, and managed. According to Michael Porter, a company's operations may be broken down into phases, procedures, and interactions that produce value to a client. Advance in solar cell research and testing, energy losses and degrading of PV modules, forecasting solar photovoltaic, radiation and electricity generation, digital technologies for PV monitoring, and metal leaching from obsolete PV waste. That's all from me. Thank you.
Hello ma'am, I'm 2190762, Surya PRAKASH TOULSIMANI. So I'm going to present the working concept of solar energy generation system. So needless to say that the sun is the biggest source of renewable energy for the earth. The fact is that even though the earth receives only a part of the energy generated by the sun, for example solar energy, that part of solar energy is also tremendously huge. The earth receives solar energy in the form of light and heat, but in today's world, the words power and energy are leaned more towards electricity. Electrical energy can be harvested from solar power by means of either photovoltaics or concentrated solar power systems, also known as CSP systems. So for solar photovoltaic technology, photovoltaics directly convert solar energy into electricity. They work on the principle of the photovoltaic effect. When certain materials are exposed to light, they absorb photons and release free electrons. This phenomenon is called as the photoelectric effect. Photovoltaic effect is a method for producing direct current electricity based on the principle of the photoelectric effect. According to the requirement of power, multiple photovoltaic modules are electrically connected together to form a photovoltaic array and to achieve more power. There are different types of photovoltaic systems according to the implementation. The PV direct systems, off-grid systems, and grid connected systems. Okay, so I'm going to explain one by one. So for PV direct systems, these systems supply the load only when the sun is shining. There is no storage of power generated and hence batteries are absent. An inverter may or may not be used depending on the type. For off-grid systems, this type of system is commonly used at locations where power from the grid is not available or not reliable. An off-grid solar power system is not connected to any electric grid. It consists of solar panel arrays, storage, batteries, and inverter circuits. So for grid connected systems, these solar power systems are tied with grids so that the excess required power can be accessed from the grid. They may or may not be backed by batteries. Next, for the type of photovoltaic technology used, there are three of them: silicon solar cells, thin film solar cells, and third V solar cells. For silicon solar cells, the vast majority of today's solar cells are made from silicon and offer both reasonable prices and good efficiency, the rate at which the solar cell converts sunlight into electricity. These cells are usually assembled into larger modules that can be installed on the roofs of residential or commercial buildings or deployed on ground-mounted racks to create huge utility-scale systems. For thin film solar cells, another commonly used photovoltaic technology is known as thin film solar cells because they are made from very thin layers of semiconductor material such as cadmium, telluride, or copper gallium diselenide. The thickness of these cell layers is only a few micrometers, that is several millionths of a meter. Thin film solar cells can be flexible and lightweight, making them ideal for portable applications such as in a soldier's backpack or for use in other products like windows that generate electricity from the sun. Some types of thin film solar cells also benefit from manufacturing techniques that require less energy and are easier to scale up than the manufacturing techniques required by silicon solar cells. Next, the third V solar cells. A third type of photovoltaic technology is named after the elements that compose them. Third V solar cells are mainly constructed from elements in group 3, example gallium and indium, and group 5, example arsenic and antimony, of the periodic table. These solar cells are generally much more expensive to manufacture than other technologies, but they convert sunlight into electricity at much higher efficiencies. Because of this, these solar cells are often used on satellites, unmanned aerial vehicles, and other applications that require a high ratio of power to watt. Next, the second type of solar power generation system, that is CSP technology or concentrated solar power technology. CSP is an approach to generating electricity in which mirrors are used to reflect, concentrate, and focus sunlight into a specific point. The concentrated sunlight is converted into heat, which in turn is used to create steam. The steam is then used to drive a turbine that generates electrical power. CSP technology is used to store solar power, so it can be used on cloudy days and in the hours after sunset or before sunrise. As of this writing, CSP is still an emerging approach to generating electricity and is most commonly used in utility-scale projects. There are four types of CSP systems: the parabolic trough systems, parabolic dish systems, power tower systems, and the last one is compact linear Fractional reflector systems. Okay, for the first one, power tower systems. Power tower systems are sometimes called central receivers. Use numerous large flat mirrors to track the sun and focus the solar energy onto a receiver. In this system, the receiver sits at the top of a tall tower and collects sunlight that is used to heat fluids, such as molten salt. Temperatures can reach up to 1050 degrees Fahrenheit. The heated fluid can either be used immediately to make steam and generate electricity, or it can be stored and saved for use at a later point. For parabolic trough system, parabolic trough system incorporate U-shaped mirrors that have oil-filled pipes running along the focal point. The mirrors are pointed towards the sun and concentrate the sunlight onto the pipes in order to heat the oil inside. Temperatures can reach as high as 750 degrees Fahrenheit. The heated oil is then used to boil water and produces steam that is used to drive turbines and generators. Next is the parabolic dish system. Parabolic dish systems employ U-shaped or parabolic mirrored dishes that are about 10 times the size of a residential satellite dish to focus sunlight onto the receiver, which is mounted at the focal point of the dish. This receiver is integrated into a high-efficiency external combustion engine that utilizes tubes holding hydrogen or helium gas that run along the outside of the engine and open into the 4 piston cylinders. As the concentrated sunlight is collected by the receiver, it heats the gas in the tubes to extreme temperatures, causing the hot gas to expand within the cylinders. This expanding gas drives the piston, which turns a crankshaft, which in turn powers the generator that produces electricity. In a parabolic dish systems, the receiver, engine, and generator from a single combined assembly is placed at the focal point of the mirrored dish. In order to capture the peak amount of solar energy, the dish systems follows the sun's path across the sky, similar to a tracking array. The last one is the compact linear Fractional reflector system. Compact linear Fractional reflector systems use long parallel rows of flat mirrors that cost less than the curved mirrors in the parabolic trough system. The flat mirrors in the compact linear Fractional system concentrate the solar energy onto rest receivers, then incorporate a collection of tubes filled with flowing water. The focused sunlight is used to boil the water, thus producing steam that can be used to generate power. That's all for me for working concept of solar power generation system. Thank you. Thank you, ma'am.
Okay, I will tell you about the example of the existing system. Okay, the first is solar in watch. Okay, a solar powered or light powered watch is one of the powered totally or partially by a solar cell. Watchmaker technology has advanced to the point that solar powered timepieces are now a significant component of the product line. Typically, a solar panel behind a crystal absorbs both natural and artificial light. This solar panel turns light into electrical energy, which is then used to power the watch. Okay, the watch will often store energy in a rechargeable cell to power itself at night or while covered. Employ lithium-ion batteries to store enough energy to operate the watch for several months or years without being exposed to light by allowing the watch to enter a power saving or hibernation mode. Okay, the second one is solar in vehicles. PV cells turn sunshine into energy, which is then used to power electric motors in solar automobiles. Okay, the quantity of energy input into the automobile sustainably limits the design of a solar car. The solar electric vehicle system was developed into a construct to be a simple 2 or 3 hour to install integrated accessory system that include a custom module, low profile solar panel, supplemental battery pack and charge regulating mechanism. Okay, the last one is solar in calculator. Handheld electronic calculators powered by solar cells installed on the device are known as solar power calculator. Because of its low performance compared to conventional crystalline silicon solar cell is more than the offset by the low cost and simplified deposition of the substrate. Amorphous silicon has been used as a photovoltaic solar cell material for devices that require very little power, such as pocket calculator. Solar calculator use liquid crystal display because they are power efficient and operate in 1.5 to 2 voltage range.
Good evening, ma'am. I am 219043 CHEN. Today I'll present the design of 5 megawatt of power plant. So to design a 5 megawatt of power plant, I assume that the feed water heater operates at steady state. Changes in potential and kinetic energies are negligible. heat transfer are negligible. No shaft work crosses the system boundary in this process. An open feed water heater is essentially a mixture which superheated vapor is used to raise the temperature of a subcooled liquid. We can begin our analysis with the steady state form of the first law of thermodynamics. So in this equation, I already simplified to find the Y, which is the mass flow rate. So this is the diagram of the power plant, and this is the TS diagram of the power plant. So we extend the open feed water heater by tapping steam from the outlet of the high pressure turbine and reduce the pressure to 1.5 megapascal by means of a throttling control valve before feeding it into the open feed water heater. This allows one to conventionally convert into an open feed water heater without requiring a bleed tap from the low pressure turbine at exact the open feed water heater pressure. So in this calculation, I already calculate. So to the end, we find that the net power output is slightly less without the turbine tap. However, power control is normally done by changing the feed water pump speed, and we normally find a liquid water storage tank associated with the open feed water heater in order to accommodate the changes in the water mass flow rate. In our case, we simply need to increase the water mass flow rate in order to regain our original power output. Thank you.
Okay, in conclusion, Malaysia's power generation is heavily reliant on coal, natural gas and fuel oil. The depletion of fossil fuel and rising petroleum price have prompted the government to focus on renewable energy in a bid to reduce its reliance on fossil fuel. Malaysia's energy needs are changing due to the depletion of fossil fuel supplies. Fossil fuel base will continue to be the primary source of the energy production in Malaysia, but carbon emissions are expected to rise in the future. The existing pattern of electricity generation cannot be continued. The Malaysian government has been pursuing solutions. Malaysia has abundant renewable energy source such as solar power. Two primary technologies, namely renewable and energy efficiency, can provide the impetus to achieve sustainable energy. The Malaysian government has a set goal of 15% in renewable energy in power generation by 2050. Malaysia plays an important role in the solar power sector, ranking third in the manufacture of the solar photovoltaic PV cells and modules. Primary focus of carbon emission reduction is on sustainable energy planning in the power production sector. Okay, the country's total renewable energy output is expected to rise from 11,227 gigawatt in 2013 to 13,540 gigawatt by 2050, which is 1.7% of its total.